Welcome, my friends! In the previous video, we discussed logarithms and dealt with logs involving all different kinds of bases, like log base 3 of 9 or log base 5 of 25. And we also talked about the two most common log bases, which are log base 10, which we call the common log, and log base e, which we call the natural log. We discussed how we typically write these special logs slightly differently. So the common log is written simply as log, with an implicit base of 10, and the natural log is written as ln, with an implicit base of e. Well, it turns out that most calculators do not have an option to do something like these guys. You can't take the log base 3, or the log base 5, or the log base anything really, besides 10 or e. Calculators usually only have two log buttons, which are the common log and the natural log. So that becomes a problem if we want to evaluate logs with bases other than e or 10 for problems that we can't do in our head. But fear not, for there is a solution, and that is called the change of base formula, which I will show you in this video, but not prove. The formula is log base a of b is equal to log base c of b divided by log base c of a. Notice what this formula does. It rewrites a log with a base of a as a log with a new base that wasn't even in the original expression, base c, first with an argument b, and then divides by another log, also with a base c, but with an argument a. The remarkable fact is that the base c can be any number that you want it to be. It can be base 5, or 10, or 12, or whatever. So why is this useful for us? Well, it means we can rewrite any log with any base as the ratio of two logs with a base that our calculator has, such as base 10 or base e. So we typically let c equal 10 or e, so that we can use the common log or natural log keys on our calculator. Take, for example, log base 4 of 25. This log asks us, 4 raised to what power is equal to 25? Well, 4 squared is equal to 16, and 4 to the third power is 64. So the answer must be somewhere between 2 and 3, but who knows what it is exactly. And our calculator, of course, does not have a log base 4 button. So without the change of base formula, we'd be out of luck. But with the change of base formula, this could be rewritten as log of 25 divided by log of 4, where the log I have written has a base of 10. I'm just using the formula. Our b value is 25, which corresponds to the numerator, and the a value is 4, which corresponds to the denominator. And our c value is 10, which is the implicit base of a log when a base is not written. Then we can pull out our calculator and type in the result. Log of 25 divided by log of 4 is equal to about 2.32. Note that we could have also used the natural log to get the same answer. We could have let our base c equal e, so that we have the natural log of 25 divided by the natural log of 4. The natural log of 25 divided by the natural log of 4 is also equal to 2.32, so you can use whichever method you want. If you are forgetting how to use the change of base formula, just remember right, left. Take the number on the right, the argument of the log, which will be the argument in the numerator, and then divide by the log of the number on the left, the base of the log. So looking at one more problem, we have log base 7 of 58. Just remember right, left. So we have log of the right number, 58, divided by log of the left number, 7. This is equal to about 2.09 if you were to type that into your calculator. Now, there's one more useful property of logarithms that I want to talk about in this video, and that is that it can be used to solve an equation involving a variable and the exponent. This property is called the power rule for logarithms, which says that log base a of x to the r power is equal to r times log base a of x. Essentially, this says that if the argument of your log is raised to some power, as we do here with x raised to the r power, the power can be rewritten out front, multiplying the log. For example, say that you have 8 to the x power is equal to 196, which we want to solve for x. We could rewrite this in logarithmic form, like we did in the previous video, but More frequently, you will use the power rule for logs to solve this. A valid algebraic manipulation to an equation like this is to take the log of both sides. So we have log of 8 to the x power is equal to log of 196. Now we can use the power rule of logs to move the exponent from the inside of the log out to the front. We have x times log of 8 is equal to log of 196. Now we can divide both sides of the equation by log of 8 to get x is equal to log of 196 divided by log of 8. Now we need to grab our calculator. Log of 196 divided by log of 8 is approximately equal to 2.54. So x is approximately 2.54. Let's try a more complicated one involving both the power rule and a change of base. Say we have log base 1/5 of 20 to the x minus 4 power is equal to 20. Well, let's use the power rule property to pull the x minus 4 exponent down to multiply the log. We have x minus 4 times log base 1/5 of 20 is equal to 20. Log base 1/5 of 20 is just a number, so let's simplify that before we move any further. Using the change of base formula, we need the log of the right divided by the log of the left. Let's use the natural log this time, but you could also use a base 10 log, of course. We have natural log of 20 divided by natural log of 1/5. Typing that into the calculator, we have the natural log of 20 divided by the natural log of 1 over 5, which is equal to about negative 1.861. I'm going to write down the rounded number, but for future calculations, I'll use all of the decimals my calculator gave me. You might have to press the store key on some calculators to remember this number, but I don't need to on this one. So we can rewrite our problem as x minus 4 times negative 1.861 is equal to 20. Dividing both sides by negative 1.861, we will need to go to our calculator again, this time to find out what 20 divided by negative 1.861 is. On my calculator, I type 20 divided by, and then I can press second, answer, to bring up the negative 1.861 with all the decimals. Or you might just have to press the recall key on your calculator. I get x minus 4 is equal to negative 10.745. Now I can add 4 to both sides to give me x is equal to approximately negative 6.745, which is the final answer, and is approximated as we did round our log within the process. Alright my friends, that finishes up our video covering the change of base formula and the power rule for logarithms.